The James Webb Space Telescope is a space telescope that was designed primarily for infrared astronomy. Its greatly improved infrared resolution and sensitivity will allow it to see things that the Hubble Space Telescope can't see because they're too old, too distant, or too faint. This is expected to enable a wide range of astronomical and cosmological investigations, such as observations of first stars and the formation of first galaxies, as well as precise characterization of potentially habitable exoplanet atmospheres. The James Webb Telescope was launched from Kourou, French Guiana, on December 25, 2021, on an ESA Ariane 5 rocket, and it's still being tested and aligned as of April 20, 2022. JWST will succeed Hubble as NASA's premier astrophysics mission once it's operational, which is expected to be around the end of June 2022. The National Aeronautics and Space Administration, or NASA, of the United States developed JWST in collaboration with the European Space Agency, or the ESA, and the Canadian Space Agency, or the CSA. Northrop Grumman was the prime contractor, and the NSA Goddard Space Flight Center, GSFC, in Maryland oversaw telescope development. The Space Telescope Science Institute in Baltimore operates JWST. The telescope is named after NASA Administrator James E. Webb, who worked on the Mercury, Gemini, and Apollo programs from 1961 to 1968. COBE, WMAP, and Planck have all been seen further back in time than JWST, and JWST will see further back in time than Hubble. JWST was designed to observe a period in the history of the universe that no one has seen before, rather than the beginning. The first objects that appeared as the universe cooled after the Big Bang can be seen. That time period is most likely hundreds of millions of years after COBE, WMAP, and Planck were designed. The first tiny temperature waves that were detected are thought to be the seeds that grew into galaxies. When and how the universe created the first stars and galaxies is unknown. That's why scientists are working on JWST to help them answer these questions. Webb has been folded up to fit these rockets' fairing, with its 6.5-meter primary mirror and tennis court-sized sunshield, only to be deployed step by step in the first 2 weeks of its mission. Now, we're waiting for the James Webb Space Telescope to take the first proper images of space, which should happen around June or early July 2022. The most recent image of the James Webb Space Telescope shows an incredible view of the Milky Way satellite galaxy, the Large Magellanic Cloud. JWST's coldest instrument, the Mid-Infrared Instrument, or the MIRI, was used to capture this image. Webb scientists can test the telescope's imaging performance by focusing on the star field of the Large Magellanic Cloud. NASA has released a pair of images that compare the capabilities of the James Webb Space Telescope to those of the Spitzer Space Telescope. Spitzer, now a retired observatory, captured high-resolution images of the universe in the near and mid-infrared. Webb, with its significantly larger primary mirror and improved detectors, will allow us to see the infrared sky with improved clarity, allowing us to make even more discoveries, said NASA in a statement. The James Webb Space Telescope has taken another step towards launching science operations in the summer of 2022. After weeks of alignment, NASA completed focusing the James Webb Space Telescope's primary mirror on the 11th of March, exceeding the original goal and resulting in the image below. An image of star 2-mass J1755404 plus 6551277, released on the 16th of March 2022. The image was significant because it demonstrated that each of the JWST's 18 primary mirror segments, which produce the Space Telescope's iconic honeycomb mirror design, has been correctly aligned. JWST has taken another step towards its beginning the cosmic exploration. The achievement marked the end of the process known as fine phasing. The main mirror of the JWST is made up of 18 hexagonal segments. To focus these, the team pointed the telescope at a lonely star chosen to be easily identified and with a few nearby companions. They then adjusted each panel so that when the 18 separate images were combined, they were aligned into a single point of light, focused within 50 nanometers, a fraction of the wavelengths of infrared light it will observe. The team then used the near-infrared camera to photograph the star. Even though the telescope was only supposed to pick up the focus star, it also picked up a scattering of background galaxies. In February 2022, the JWS team released an image of 18 different stars scattered across a black background. Since JWST's mirror segments were still being aligned, the star was visible in 18 different positions. This seemingly chaotic capture was caused by JWST's misaligned mirror segments, reflecting light back into the telescope's instruments. And it was an important step in preparing Webb to produce beautiful images of the universe. We aligned and focused the telescope on a star, and the performance exceeds expectations, says Ritva Keskikuha, JWST's deputy's optical telescope element manager. The JWST team set out more than 20 years ago to build the most powerful telescope ever put into space. And they came up with an optical design to meet the science goals, says Thomas Zerbuchin, Associate Administrator for NASA's Science Mission Directorate. The first in-focus image from one of JWST's cameras is enticing and promising astronomers' future riches. In contrast to the previous infrared image of the region from Spitzer and the WISE space telescopes, which showed an array of blobs, Webb's image shows sharply focused galaxies that reveal structure in even those distant background sources. We can piece together the life stories of these obscure galaxies thanks to JWST's exceptional resolution. Although we only have this single image, we know the camera imaged the field using multiple filters. The brightness of the galaxy in each of these would allow us to make an educated guess at its distance, and thus how far back in the universe's history we're seeing. This isn't the point of these images, as there will be more soon, but it's a tempting thought. So, where is the James Webb Space Telescope these days, and when will science operations begin? 3 mid-course correction maneuvers place the massive space telescope in a slow looping orbit around the second Lagrange point, L2, a stable gravitational point 1.5 million kilometers behind Earth, as seen from the Sun. However, a lot more work needs to be done before we can begin science operations, says Mark McHogran, Senior Advisor for Science and Exploration at ESA, the European Space Agency, NASA's main partner in the program. For one thing, the telescope and its sensitive instruments must cool down to 230 degrees Celsius below zero after leaving the French Guiana launch platform at tropical temperatures. JWST has already reached negative 200 degrees Celsius thanks to its massive multi-layer sun shield by early January 2022. But passive cooling slows over time. McHogran describes the process as delicate. These optics must never be in the coldest parts of the telescope, lest the molecules released as gases from the graphite composite support structure freeze and damage the mirrors. The process of aligning the telescope's 18 mirror segments could finally begin when the NIRC CAM instrument, near-infrared camera, became cold enough for its sensitive mercury-cadmium telluride detectors to pick up infrared light. Each hexagonal segment has 7 actuators and can be slightly tilted, shifted, rotated, and deformed to operate as a single perfect parabolic surface. Since the alignment procedure is done with starlight, the images above represents JWST's first light. However, it'll take months of incremental precision adjustments to bring the 18 individual stellar images from each mirror into one single focus. Engineers will begin commissioning JWST's 4 large science instruments, including the NIRC CAM, the near-infrared camera, the NIRS SPEC, the near-infrared spectrometer, the MIRI, mid-infrared instrument, and the FGS/NIRISS, the fine guidance sensor/near-infrared imager and slitless spectrograph, in late April 2022. All of the observing modes, which are equipped with beam splitters, filters, and microshutters, must be thoroughly tested and calibrated before being released to the astronomy community. The first images from JWST aren't expected for another 6 months after launch, in late June or early 2022. It is closely guarded secret what it will reveal. It's most likely a star-forming region, McHogran agrees. The first round of science observations will not begin until the summer of 2022. Astronomers are eager to use their new expensive toy and their favorite objects, whether it's a distant galaxy from the dawn of time, a planet-spawning accretion disk, an exoplanet's atmosphere, or a creature from our own solar system. The pointing flexibility of the James Webb Space Telescope is less than that of the Hubble Space Telescope. Since the telescope must face away from the sun to keep its instruments cool, its field of regard will cover 40% of the sky on any given day, and accessing the entire sky will take about 6 months. JWST's mid-course corrections consumed less fuel than expected, indicating that there's still enough fuel to keep the space telescope in its L2 orbit. As a result, its operational lifetime could be extended beyond the 10 years it was originally planned for. And that's all for today's video. Thanks for watching. If you enjoyed the video, then do like, share, and subscribe to the channel for more such exciting content. I'll see you in the next one.